Our Sun is about 109 times the diameter of Earth, and it is so large that 1.3 million Earths can fit inside of it. But compared to other stars, our Sun is an average-sized star. The biggest star that we humans have identified is the red supergiant Stephenson 218 in the constellation of Scutum. It lies about 19,000 light-years away from Earth in the Scutum-Centaurus arm of the Milky Way galaxy. Stephenson 218 has an estimated radius of around 2,150 solar radii, which would correspond to a volume nearly 10 billion times that of the Sun. Taking this estimate, it would take nearly 9 hours to travel around its surface at the speed of light, compared to 14.5 seconds around the Sun. If placed at the center of Earth's solar system, its photosphere would engulf the orbit of Saturn. As Stephenson 218 continues to burn elements in its core, it will eventually die with a supernova, giving its mass back to the galaxy. This mass will create new stars and planets. However, Stephenson 218's large radius does not make it the most massive or heaviest star. That honor goes to the star R136A1, located about 160,000 light-years from Earth in the Large Magellanic Cloud, a small galaxy that orbits the Milky Way. This star is also relatively young, roughly 1 million years old, compared with our Sun's 4.5 billion years, and it weighs in at about 300 times the mass of the Sun, but only about 30 solar radii. Stephenson 218 in comparison is only about 30 to 50 times the mass of the Sun, but far greater in volume. That's because as stars get older, they tend to expand and shed mass. Due to its massive size and intense luminosity, the R136A1 will burn out its fuel very quickly. Given its nature, it will eventually suffer from a core collapse supernova and will most likely become a black hole. How long a main sequence star lives depends on how massive it is. A higher mass star may have more material, but it burns through it faster due to higher core temperatures caused by greater gravitational forces. While the Sun will spend about 10 billion years on the main sequence, a star 10 times as massive will stick around for only 20 million years. A red dwarf, which is half as massive as the Sun, can last 80 to 100 billion years, which is far longer than the universe's age of 13.8 billion years. This long lifetime is one reason red dwarfs are considered to be good sources for planets hosting life, because they are stable for such a long time. Eventually, the hydrogen which powers the nuclear reactions inside a star begins to run out. The star then enters the final phases of its lifetime. All stars will expand, cool, and change color to become a red giant. A smaller star like the Sun will gradually cool down and stop glowing. A massive star experiences a much more energetic and violent end. It explodes as a supernova. This scatters materials from inside the star across space. This material can collect in nebula and form the next generation of stars. After the dust clears, a very dense neutron star is left behind. If the star is especially massive, when it explodes, it forms a black hole. That's all for today's video. Like and subscribe to the channel, and see you in the next one.